So for the past few days, we've been sort of using this concept of the unit circle to inform our knowledge of trigonometry and the trig ratios and what they mean and all that stuff. And up to this point, it's all been really approximation heavy. And what I mean by that is we haven't really been going for exact values. We've been going for estimates of these things. And with today, we're really talking about memorizing the exact values of key values around the unit circle. And before I get into this, I need you to recall two things. I need you to recall 45, 45, 90 triangles, and I need you to recall 30, 60, 90 triangles. And depending on how or where you learned this, you may remember this differently, but I'm going to go through it quickly. A 45, 45, 90 triangle is basically just a triangle that has a 90-degree angle and has 45-degree angles for both of these things. I think that most people, when they learn that this is 1, and this is the square root of 2. Right. 30, 60, 90 triangle, really similar. The difference is that in this one, you've got the 90-degree angle, you've got 30 degrees, you've got 60 degrees. And I think the way that most people have this memorized is that the small side is 1, the hypotenuse is 2, and the long side is the square root of 3. If you don't remember that, review that, look over that, make sure that makes sense. Now, I'm going to be working with a unit circle. And so in a unit circle, I want my hypotenuse to be 1, and I think we talked about that in one of the previous videos. So I actually want to modify both of these. I want to scale both of these down, right? So when I scale down the 45, 45, 90, I divide everything by the square root of 2, and what I end up with is this being 1, and each of these being 1 over the square root of 2, but 1 over the square root of 2 can be rewritten as the square root of 2 over 2. So we're sort of working with the idea that when you're in a 45, 45, 90 triangle, the sides are both the square root of 2 over 2. Okay. In the one over here on the right, it's actually a little bit easier for 30, 60, 90. I just need to divide everything in the triangle by 2. And when I do that, I end up with the hypotenuse being 1, just like I need it to be, the short side being 1/2, and the long side being the square root of 3 over 2. So what you're going to see through this video is that when you're working with 30, 60, 90-ish stuff, a half and the square root of 3 over 2 are the values you're working with. Now the next slide I'm going to bring up is scary, and it's intended to be that way, so don't run screaming out of the room when you see it. Alright, so this is the table of trigonometric values that you need to have memorized. I expect by, the end of today, that you'll be able to generate this table. And like I said, it's supposed to be frightening, because you're like, that's a ton of information, what the heck? So first of all, let me make sure you can read this table. What this means is if you wanted to know what the secant of 3 pi over 4 is, you would follow secant and 3 pi over 4. Okay, the secant of 3 pi over 4 is exactly the negative square root of 2. Right? The sine of 5 pi over 4 is exactly negative square root of 2 over 2. The cotangent of 5 pi over 4 is exactly 1. So the idea is there is a ton of information here. I mean, there's a ton of it, right? The unit circle gives you a way of organizing all of this information so that you can easily recall it at any time without having to spend hours making flashcards, memorizing, looking at these things. So the next slide I'm going to sort of show you how the unit circle presents this information. So here's a unit circle with key values sort of indicated on it, right? So what you see here is, and this isn't surprising, we've talked about this before, that you sort of got 0 here, a 90-degree angle is up here. That 90-degree angle is also called pi over 2. Right, 60 degrees is here. You've sort of got, there's your 60-degree angle. And what we've done here is we've sort of labeled for each one of these points what the coordinates of those points are. Right? So when you're looking at a 30-degree angle, the coordinates of that point are square root of 3 over 2 and 1/2. And the reason that's exciting is that we sort of we remember that the cosine of an angle is the x-coordinate, and the sine of an angle is the y-coordinate. That was a bad x, but the sine is the y-coordinate, right? So if we can have all of these coordinates, I don't want to say memorized, if we can know all of these coordinates, we can effectively come up with all of the trig ratios, right? Now some of you may be curious as to where these values are coming from. I'm going to zoom in here so I can sort of show you that. I had mentioned that I really wanted to make sure you knew 30, 60, 90, and 45, 45, 90 before we started this. So take a look at this. If you look at this 30-degree angle and construct this, well, if you think about it, this is going to be a 30 That's a 90-degree angle. This is a 60-degree angle. This is a 30, 60, 90 triangle. We know this hypotenuse is 1. Why is it 1? Well, it's 1 because this is a unit circle. If that's 1, then the short side will be 1/2, and the long side will be the square root of 3 over 2. And, oh my gosh, crazy, this square root of 3 over 2 is the x-coordinate of this point, and therefore the cosine of 30 degrees. And the y-coordinate of this point, 1/2, well, it's the y-coordinate. That means it's the sine of 30 degrees. And so the idea is we can look around the entire unit circle and pick any angle and effectively figure out what the sine or cosine or any other trig ratio of that point is. Right? Now, again, you may feel like, well, this is just as bad. I still have to memorize this whole freaking circle. Like, how am I supposed to do this? The key thing I want you to notice, and I'm going to write out steps for this in the next one, I want you to look at all of the points around the circle. And I want you to notice that really, there are effectively only 5 different values for x and y. There's 0, there's 1/2, there's the square root of 2 over 2, there's the square root of 3 over 2, and there's 1. Like, these are the 5 values that you need to know. And technically there's negatives in there also. But if you look at every single one of these points, like this, this one down here, this has a square root of 2 over 2 and a negative square root of 2 over 2. Right? This point over here has a negative square root of 3 over 2 and a positive 1/2. The reality is that these are sort of the only 5 values that you really need to have memorized. And you just need to know that this is the short side, this is the medium side, this is the long side, and it's going to sound silly, but this is 1 and this is 0. Okay? So in the next slide I'm going to go through the steps for how we use the unit circle, and then after that we're going to get into some practice. Alright, so here are my steps in evaluating trig functions using the unit circle. So step 1 is basically, find out where the angle is on the unit circle. And eventually you're going to be able to do that mentally. In the beginning you are probably going to need to draw a unit circle each time. And it doesn't need to be amazingly accurate. You don't need to fill in the whole thing. You just need to draw yourself a circle and identify where the angle is that we're looking at. The second step is to identify the coordinates of that point on the unit circle. And you're supposed to use those 5 key values. And remember, the 5 key values were 0, 1/2, the square root of 2 over 2, the square root of 3 over 2, and 1. When you identify the coordinates of the point on the unit circle, it will always be a combination of 2 of these values, right? And to be honest, it will either be 0 and 1, 1/2, and the square root of 3 over 2, or the square root of 2 and itself. Okay? Now we do need to keep in mind that negatives can be in there too, but as you're going to see when we do some practice on these, it's going to be clear whether it's positive or negative. And then the third thing is we have to determine the appropriate value using the memorized ratios, and I'm going to go over those right now. The first 2 ratios that are quite easy are sine and cosine. We know that the cosine of an angle is simply the x-coordinate on the unit circle. Similarly, we know that the sine of an angle is the y-coordinate on the unit circle. And technically, if you want a ratio for those things, I suppose it's x over 1, and it's y over 1. But realistically, we end up just going with the idea that cosine is the x-coordinate, sine is the y-coordinate. Okay? The next 2 that are fairly easy to work with from there are the reciprocals of these. The reciprocal of cosine is secant. So the secant of theta is going to be 1 over the cosine of theta, which effectively means that it's 1 over whatever the x-coordinate is. Right? Similarly, the reciprocal of sine is cosecant. So cosecant theta is 1 over sine theta, which means the cosecant will always be 1 over the y-coordinate. The last 2 that we have are tangent and cotangent, so I'll go over those last. The tangent of an angle, tangent is equal to the sine of theta over the cosine of theta, which means according to the unit circle it's going to be the y-coordinate over the x-coordinate. And then the last one is the cotangent of theta, And cotangent is effectively 1 over the tangent of theta. And so, realistically, what that's going to do is it's just going to do the reciprocal of this y over x business. It's going to be cosine over sine, which is x over y. So, and I know I'm asking you to memorize a lot here, and this is going to take a lot of practice, but if you devote yourself to some practice, you're going to get really fast at this, and it's awesome. It's also incredibly valuable in calculus and on the IB exams. You basically need to know that cosine is the x-coordinate, sine is the y-coordinate, and then have these things memorized as well. If you've got those memorized and you can picture the unit circle, you're going to become a trigonometric fiend. So let's go ahead and take a look at some example problems. Okay, so I have a lot of example problems here, and to be honest, what I'm going to do is I'm going to zoom the video in so that you can see each one of these, and we're going to write sort of a whole unit circle next to each one of these things. I'm going to go down all of the degree ones first, and then all of the radian ones, so feel free to sort of like jump around and, you know, skip the video ahead or come back and look at what you need to do. After we've done a few of them, I really want you guys to try them on your own and just give this a shot, because this is definitely a skill that I mean, this needs to become like your times tables, where you can do this quickly. It's not going to be quite that fast, but it needs to be something that you can do quickly. Alright, so let's see what we have here. So first up, we're looking at the sine of 60 degrees. So the way that this works, you know, we talked about this 3-step method before. We start with a unit circle, right? So you draw your circle, you sort of put your axes through it, and then we think, okay, where is 60 degrees? Right? And until you get these memorized, my thoughts a lot of times really go, like I'll sort of say, well, this is 0 and this is 90. 60 is 2/3, like this would be 30, this would be 60, this would be 90. So you've got this idea that 60 degrees is sort of up here, and if you sort of go through that point, my thought always goes to, you know, if you think about that point, the x-coordinate is short, the y-coordinate is long, and if you think about our options, the options of 0, 1/2, the square root of 2 over 2, the square root of 3 over 2, and 1, the quote-unquote short and long options are 1/2 and the square root of 3 over 2. So remember, step 1 was draw the unit circle, locate the angle. Once you've located the angle, the next step is write down, or at least think about what the coordinates are. Then once you have the coordinates, you go, okay, well, I want the sine of that angle. Sine is supposed to be the y-coordinate, so the sine of 60 degrees is the square root of 3 over 2. And that's the exact value of the sine of 60 degrees. Okay, let's go on to the next one. So next up is the cosine of 135 degrees. So the cosine of 135 degrees, so again, we start with a unit circle. We draw our circle. Do this. Now, a negative angle means I go backward, right? And you may be wondering, well, where's 135 degrees? What's that about? Again, until you get the hang of this, I really feel like using 90 degrees as a benchmark helps a lot, right? So 135 degrees we could think of as being, 90 degrees, so we go 90 degrees first. Then we're going to need to go 45 degrees past that to get to 135. So the idea is, oh, okay, I went 90 degrees, now I just go 45 degrees, I go to here. And this triangle, notice that this one doesn't have, like the previous one, had a short and a long side. This one, because it's a 45 style triangle, has two sides that are the same lengths. They're both the square root of 2 over 2. So now we just have to think carefully about what that point is, right? We know that it has to do with the square root of 2 over 2. But because the x-coordinate is backward and the y-coordinate is downward, we're going to have negatives on both of these. That coordinate is definitely negative square root of 2 over 2, and then negative square root of 2 over 2. Right? And now we're almost done. The cosine of that, remember that the cosine is supposed to be the x-coordinate, so the cosine of negative 135 degrees is the negative square root of 2 over 2. Yay. Right? This is how all of these unit circle problems work. Like this is how I do these problems. I know that some people advocate that you actually memorize the unit circle. I was never good at memorizing. And so for me, being able to picture the unit circle, being able to sort of visualize these angles, find the coordinates, and then come up with a point is the way that it's always worked for me. Now I'm hoping I can keep my commentary down on the rest of these problems so that we can get through them more quickly. But we're just going to keep going, right? So the tangent of 120 degrees. Just like before, we draw our unit circle. We think where 120 degrees is, that would basically be 90 degrees plus another 30 degrees. So that's sort of up here. Right? And we need the coordinates of that point. So again, we're thinking about this and saying, hey, vertically it looks like a long distance. Horizontally it looks like a short distance. So that point up there, the x-coordinate is short and negative, so that means negative a half. The y-coordinate is long and positive, therefore the square root of 3 over 2. The next thing we need is tangent. Remember that the tangent of an angle is supposed to be sine over cosine, which means it's y over x. So we just do the ratio of the square root of 3 over 2 over negative 1/2. If I multiply top and bottom both by 2, these 2's will eliminate, those 2's will eliminate. Long story short, the answer I'm going to end up with here is the negative square root of 3. And that is the tangent of 120 degrees. Next up, the secant of negative 90 degrees. Okay, this one should be fairly quick. Unit circle, negative 90 degrees means down this way, all the way down to the bottom. So we're looking at that point. Coordinates of that point are 0, negative 1. And I really hope as you guys do more of these problems, you're going to get faster and faster about identifying those coordinates. Now the secant. The secant of an angle is supposed to be 1 over the cosine of that angle. So that means for us 1 over our x-coordinate. We end up with a 1 over 0, which is undefined. Yeah, division by 0 is never allowed. 1 over 0 is just undefined. Turns out a lot of calculus is going to be us exploring. So like, what is 1 over 0? What is that about? But we're not there yet. So for now, undefined. The secant of negative 90 degrees is undefined. The last one of our degree ones is the cosecant of 150 degrees. I've got all kinds of space for this one. So we'll draw a huge unit circle on this one. It's a huge unit ellipse there. 150 degrees. So I'm thinking of that as being 90 degrees plus another 60 degrees. Some of you might have thought of it as 180 degrees coming back 30 degrees. Either one of those is fine. If you can peg that angle being over here, you're winning. Right? We think about this point here and we sort of think about the y and the x coordinates of that point. Seems like that point is to the left a long distance, so that would be negative square root of 3 over 2, and then up a short y distance, so that'll be positive a half. Finally, we just remember that cosecant is supposed to be 1 over the sine of an angle, which is 1 over y for us. That gets us 1 over a half, which gives us 2. So the cosecant of 150 degrees is 2. So now we're going to move over to the radian side of things, because we had a bunch of those to work with as well. Sorry, I had to just kind of jump the video over there. I got lost in my zooming. So the cosine of pi over 4. So now radians, I know radians are not as natural for us, so this may take a little bit more work. So the cosine of pi over 4. I still am going to use, quote-unquote 90 degrees, which means pi over 2 as sort of a reference point for me. Remember that if halfway around the circle is pi, then half of that is pi over 2, and half of that is pi over 4. Now again, once you've located that point, we're just looking at what are the x and y coordinates. They both seem the same, which means this is going to be root 2 over 2, root 2 over 2. Cosine wants the x coordinate, so our answer is the square root of 2 over 2. Next up is the sine of negative pi. So the sine of negative pi, we take our unit circle. This time we're going to go backward pi, so we're going to go all the way back to here. So that's the point that we're looking at. The coordinates of that point are negative 1, 0. Sine is supposed to be the y coordinate, so the sine of negative pi is 0. Remember, if I'm going too fast, you can pause this and rewind and look at it again. Let's keep going. The cotangent of negative pi over 3. Alright, so this one, unless you've got those angular values memorized already, this one may be a little bit stranger, but I'm going to explain the way I think about it. I really see this as, okay, if pi takes me all the way around, you didn't see that, if pi takes me all the way around to here, I want 1/3 of pi. So you can think about, like, well, if I took this whole half of the circle and cut it into thirds, this would be 1/3. this is negative pi over 3. So that has a short x-coordinate, a long y-coordinate. The x-coordinate is positive, the y-coordinate is negative. Now we want the cotangent, or there's more steps to this. Remember that the cotangent of an angle is 1 over the tangent of that angle, which is supposed to be basically x over y. And so for us, that's going to be 1/2 over negative root 3 over 2. What's going to happen is that the 2's are going to cancel out. I'm going to be left with negative 1 over the square root of 3, which is a totally acceptable answer, but I know a lot of you have been trained to not have radicals in the bottom, so if we rationalize, we'll get that, which is effectively the same thing. All right, I think we just have 2 of these left. If you're still with me, good for you. Stay the course. 7 pi over 6. What the heck is 7 pi over 6? We draw our unit circle. Right? Usually I hate mixed numbers, but this is one place where I'll accept them. Think about what 7/6 means. It means 1 and 1/6. So you could think about 7 pi over 6 as being 1 pi plus an additional pi over 6. So that angle right there represents 7 pi over 6. We can tell that the coordinates here are a long negative x value and a short negative y value. So the coordinates are negative root 3 over 2 and negative 1/2. Then cosecant. Cosecant of theta is supposed to be 1 over the sine of theta, which means 1 over y. So for us, that's 1 over negative 1/2, which is negative 2. And that is the cosecant of 7 pi over 6. Last one, the secant of negative 5 pi over 4. We're going to use the same trick we did on the previous one. If you think about the fact that 5/4 is 1 and 1/4, one of the rare times that you'll hear me talking about mixed numbers, we can think about this on the unit circle as being negative pi and 1/4. This angle right here is negative 5 pi over 4. The x and y coordinates here seem to have the same length. The only difference is that the x one is negative, the y one is positive, and the last thing we have to do is do the business of secant is 1 over cosine, which means it's 1 over x, so we're looking at 1 over negative root 2 over 2, which will transform into negative 2 over root 2, which if we simplify is just negative root 2. That is the secant of negative 5 pi over 4. Now that we've come to the end of this monstrously long video, I'll apologize that it was so long, but I do have to say the unit circle is just a huge piece of our understanding about trig. The fact that we've had 3 entire videos devoted to how this thing works and the theory behind it means that, to my mind, this is more than just memorization. This actually comes to the heart of us understanding what this trig is, where it comes from, and what we can do with it. I hope that you guys sort of understand this method and that you'll be able to sort of practice the magic of knowing these things and memorizing them and being able to come up with them on the fly. So go drink some water, take a little break, and I'll see you in the next video.